time to record this video. So hi guys, welcome back to another video. My name is Salko and this is the third video in our Raspberry Pi Perfect Tiny Home server series. Today we are going to configure a DNS server based on bind. So if you're ready, let's begin. First thing that you need to do is install apt-get install bind9. So this is the first package, and dnsutils. This is the second package, which contains a couple of utilities. Bind9 is the actual server package. Press enter. You should be prompted to confirm. Yes. I will not be prompted because I have already went and installed this package, so you guys don't have to wait. Next thing that we need to do is we need to create a zone file. So we're going to create two zone files. First zone file will contain the host names, and second zone file will contain the IP addresses. Well, both of them will contain IP addresses, but the first one is the normal zone file, and the second one is the reverse pointer file. Nano etc bind, and then you can name your zone file based on what your domain name is. So I've created a couple of steps here so you can see what we're going to be doing. So we have installed bind and DNS utilities. Create the DNS zone file called db.salcohd.com. So this is my domain. This is my domain name, salcohd.com. You guys, if your domain name is called example.com, which I bet it's not, so name your zone file according to your domain name, db.salcohd.com. So I have already created this file. As you can see, we have a couple of things inside here, and by the way, I will post all of these contents of these files. I will post them online, so you guys can just copy paste and then modify according to your own needs and preferences. Let me just quickly go ahead and explain what these things are. This first thing here is a variable which can then later be reused wherever you don't specify exactly what your domain name is. Second thing which is important here is this one. It's called SOA, or Start of Authority. Every domain name has to have this. This is basically saying, okay, the domain name server, the DNS server for this domain name is this one. This is actually an email, but you cannot use the @ sign here, so you use a dot. So this is admin@salcohd.com. I could also put sorry. I could also put salco.salcohd.com. So this means that this is my email, salco@salcohd.com, the email of the administrator of the domain. Okay, let me quickly go through these things here so I can explain to you what they mean. So the first thing is the timestamp that changes whenever you update your domain. So in my case, it's not a timestamp, as you can see, but you can start incrementing like this. 1, and then you make another change. 2, 3, 4, 5, 6, doesn't matter. This is the serial number, and you guys can make this something of your own, so you don't have to do it this way. Next thing here is the refresh, the time before the zone should be refreshed. The next thing here, I have 2 hours. The time before a failed refresh should be retried. The third thing here, let's say 1, 2, 3 more. The fourth thing here, let me just put this serial inside here. For weeks, the upper limit before a time zone is considered no longer authoritative. And the last thing here is the negative cache. This basically means how long a resolver should consider a negative result for a subdomain to be valid before retrying. So yeah, there's that. Okay, next couple of things here that we have. This is where we specify the name server record, the DNS record. This is the mail server record or the MX record. With this record, we specify which is the primary responsible mail server for this email, for this domain name. So in my case, it could be mail.salcoag.com. The number 10 here stands for, this is basically the weight or the priority, if you want to call it this way. This means that if I had more than one email server, the lower the priority, the more important the mail server is. So if I have, let's say, 4 email servers, one with the priority 10, other with 20, 30, 40, right? When I receive an email, the email will be delivered to the mail server which has the lowest priority. In case that mail server is not responding, so let's say something happens with that mail server, then the next email server with the next lowest priority gets that email delivered too. This is called DNS load balancing. More on that on another day. Here we have an A record which basically tells, okay, you have a domain name. Let's give it an IP address. This thing is empty here. As you can see, nothing is written here because it's using this. It's using this zone. It's using this variable here. Also, even if I didn't specify this variable here, it could use the one from the previous line, but in my case that wouldn't be good because I have the MX record here. But anyway, not really important in our case. Here we are actually specifying which IP address does the name server 1, so this record, which IP address does it point to. Here I have a couple of other records for this is my main computer, the mail server, for example. Here we have the canonical name or Cname record, which is basically a pointer record, and it points to my domain name. So basically it means that it's pointing to salcoag.com. So the canonical records are pretty useful because you don't have to change them in case something changes. So let's say you have, I don't know, 100 Cname records. You only need to change the one which they're pointing to, and then they get updated. So that's that. And then I have another Cname, and then I have another A record here. But yeah, that's pretty much it. This is for this zone. This is the explanation, and it's pretty simple. As you can see, DNS, at least these basics are simple. Let's move on to the next step here. We need to create IP to name mapping with a file called db. And then the IP address. My IP address, as you know from this whole tutorial, begins with 10.69.69. This is my local IP address. By the way, guys, inside this file, if you have public IP addresses, you can configure them here. This is, currently I'm showing you examples with private IP addresses for myself, and I can resolve them locally. But you guys could also go ahead and put, for example, if you have a web server on another IP address, you could just create an A record here and then point it to this IP address. Okay, and then whoever wants to access your web server would then resolve this domain name there. And yeah, you would also have to put the public IP address here for the record itself. I of course will not be putting my public IP address here, so you guys don't security, but you understand what I'm trying to say. If you don't, please send me an email, post a comment, ask me on Google+, wherever. I'm here. Okay, better ask me on Twitter, because let's say I'm pretty much constantly on Twitter. So moving on to that second file which we need to create, second zone, it's called etc bind db.10.69.69. so if you guys have an IP address of your server which starts with 192.168.1 or 192.168.168.0, you should name it accordingly. So 192.168.0 or 192.168.1. For example, I'm just saying. You can remove everything from your file that you have, paste what I have here, because that file is filled mostly with comments and it looks like it has a lot of things inside, but in reality it's pretty empty. Only thing you need to do is then modify your reverse pointers. So over here again we have start of authority, just like we have in the previous file, and here I actually have a couple of information for my domain name, couple of things for my domain name. Again, here the email, the name server, we already went through this. If I just put an @ sign, it's using my domain name, so salcohd.com. I could also write salcohd.com and then dot at the end, which is obligatory, but this saves time in writing. And now, as you can see, things look a bit strange here. They are in reverse. So from up to here it says 10.69.69.62, and this is pointing to salcohd.com. And then I have here 10.69.69.69, and this one is pointing to a pointer record to optimusprime.salcohd.com. And then I have the 10.69.69.122. It's pointing to laptop2.salcohd.com. For example, you should use your own IP addresses. Also here, your own IP addresses. And that's pretty much it. It's just a reverse pointer for the previous file. So one is for host domain names, this one is for IP addresses. So if someone was to make a dig query for an IP address, which I use somewhere, then then a server could then get a result. So if someone from my network was to do this, he would get a result from my DNS server. Next thing that we need to do is change this file here, modify the bind configuration file. So nano etc bind named.conf.local, and over here as you know, we have just created these two files. One was db this one and another one was db this one, and by default bind doesn't know that these two files exist. Now we need to tell bind, okay, I made two files, please include them because they are important. So inside here we tell bind that we create two new zones. Again, my domain name, it's master, it's authoritative, and it's located here inside this folder. Same thing for the second file, it's located here. Pretty logical, nothing to it. Moving on. Last file that we need to modify is named.conf.options. Also, this file is usually filled with comments. Remove everything, paste only this thing here that I have, and let's quickly go through it. Important thing to notice here is this one. What happens when our domain name doesn't know something that we're asking it? What happens if our DNS server doesn't know something that we are asking it? Let's say I want to know what's the IP address for Microsoft.com. Okay, good, but my DNS server is not the server which is responsible for this domain name. Well, in this case, it's going to go and ask another DNS server which has this information. So in my case, I have configured Google's public DNS servers, and they have a lot of these things cached inside of them. So if my domain name server doesn't know something, it's just going to ask Google's public servers. They are fast, they are secure, and you guys should use them as well. You could put other DNS servers here, like, I don't know, your ISP, your internet service providers, DNS servers, but I recommend Google any day. Next thing which you should remember is this thing here. Allow query cache 10.69.69/24. Basically what I told my name server here is unless someone is coming from this IP address range, so 10.69.69.1 up to .254, so from this subnet, don't give them any results. So this is how I prevent anyone else other than people coming from these IP addresses, from this IP address range, to use my DNS server. Why? There is a lot of reasons. DNS poisoning could be one of them, which pops up in my mind first, but security is important, so you guys know this. This is it for configuration. As I said, it's not much to it. It's to configure a DNS server. Basic configuration is pretty quick. Close this, Control X. Now we need to check our configuration files if they are okay. We use this command, named check conf, and if this command doesn't return any feedback, if you don't get anything, it means you're good to go and you can restart your name server. etc init.d bind9 restart. To check if everything is okay, let's check log files at tail-f var log syslog. If you were to have any errors, you see here it says named. Named is the actual process which is running when you install bind. So this is the actual name server. You will not see bind9 inside here. You will see named. Name daemon, I think, at least. Anyway, you see it loaded a couple of zones. All zones are loaded, running. Otherwise, you would see something here. It says error, failed, whatever. Now let's see how our server works. You can use that command that I mentioned before, dig. It's part of those DNS utilities that we installed. And then, using @, you specify which name server to ask. My name server is running on 10.69.69.62. And now what would I want to ask it? Well, for example, I want to ask my DNS server, what's the IP address for harvard.edu. I think this domain should exist. I hope it exists. Anyway, yeah. So it gave me a result, and the time it took to give me this result was 144 milliseconds. Now, if I was to do this test again, it would take only 1 millisecond. Now my DNS server has cached this result. This means that whoever is using my DNS server after this will get a cached feedback, and then based on those settings, the expiration times inside the zone file, that's how long it will take for my DNS server to drop that information from the cache. But let's take another domain that I haven't checked. Let's say I didn't check, let's see, twitter.com. Okay, here we go. This is something which actually works, which actually exists. So twitter.com, we have an A record, this one and this one and this one. It has multiple name record. It has multiple A records, and it took 57 milliseconds to complete. Now if I check again, 11 milliseconds, so much faster. Milliseconds might not seem a lot, but if you have a lot of computers, if you have a large amount of devices, it can make a difference. And you know, that snappiness when you open a website, it's noticeable, even though the numbers are appear low. Sometimes it's not going to be 150 milliseconds, it's going to be 3000 milliseconds, and this saves a lot of time. So that was it. I hope you enjoyed the video. If you liked it, please put a thumbs up. Also, please subscribe. It means a world to me. Yeah, so I hope you enjoyed it. Also, please check out my previous videos, and my next video will be up shortly. It's going to be about PyDio, the Dropbox replacement. So there's that. Thank you and have a nice day.